Hello everyone, in this video we're going to explore Big 4 Taylor series FRQs that most tested on the apcalculus BC exam. Question 14. Let H be a function having derivatives of all orders for s greater than 0. Select the values for the function h and its first four derivatives are indicated in the table above. The function h and these four derivatives are increasing on the interval 1 to 3. Question A. Write the first degree Taylor polynomial for the function h about s equal 2 and use it to approximate h of 1.9. Is this approximation greater than or less than h of 1.9? Alright, first we have the Taylor polynomial expansion for the function h is given by the formula where c is the center, so c equals 2 right here. Now we only need the first degree Taylor polynomial, right? So we have T1 of s equals h of c, which means h of 2 plus h prime of 2 times s minus 2. We stop right here, right? So this is the first degree. Now we substitute values. H of 2 is 80 right here. Plus h prime of 2 is 128 right here. Times s minus 2, right? Now we need to calculate T1 of 1.9, right? So it's going to be 80 plus 128 times 1.9 subtract 2, it could be negative 0.1, right? Now if you use a calculator, this guy actually 67.2. We need to compare this guy right here with this guy. Since the second derivative of the function h of s is greater than 0 and increasing for s between 1 and 3, the function is concave up. So the tangent line is below the graph, right? It's going to be like this, tangent line is right here. Therefore, T1 of 1.9 less than h of 1.9, right? So the approximation is less than the actual value. Now let's move on to question B. Write the third degree Taylor polynomial for the function h about s equal 2 and use it to approximate h of 1.9. Alright, so we're going to go back to this formula right here. The third degree Taylor polynomial, we're going to stop right here. Right? Now we need to use the value of this guy, this guy, this guy, and this guy from the table right here, right? And then we're going to simplify it, right? So we have, now we need to calculate T3 of 1.9, right? So substitute 1.9 for s and use the calculator. The answer should be approximately. Question C. Use the Lagrange error bound to show that the third degree Taylor polynomial for the function h about s equal 2 approximates h of 1.9 with an error less than 3 times 10 to the negative 4. Now remember, the remainder for a third degree Taylor polynomial is for some z between 1.9 and 2 right here. This is c, right? This one is s, and z is between c and s, right? So maximum of this one when z equals 2 right here, because 2 greater than 1.9, right? So we have absolute value of the four derivative of h at 2 over 4 factorial, it could be 24, right? Times s minus 2, right? Now, the fourth derivative of h at s equal 2 is given right here. 584 over 9, right? So it's going to be 584 over 9 divided by 24, right? Times s right here equals 1.9, subtract 2, it could be negative 0.1, right? So when you raise to the 4, it's going to be positive, right? So I don't need to put this guy inside the absolute value sign anymore, right? Now you're going to print up the calculator. Hit the button right here, input the fraction. Press Ctrl Enter. It's going to be 0.00027, right? It's the same thing as 2.7 times 10 to the negative 4, right? And this guy actually less than 3 times 10 to the negative 4, right? Now let's move on to question 15. Let f be the function given by f(s) equals e to the negative s squared. Write the first four non-zero terms and the general terms of the Taylor series for the function f about s equals 0. So the center equals 0, and then this guy becomes Maclaurin series, right? And you know that e to the s equals, now you need to substitute negative s squared for s right here. So we have e to the negative s squared equals, and we need the general term, right? So plus etc. plus the general terms right here. So it could be negative s squared all together raised to the n over n factorial, right? Now we're going to simplify this one, so it could be, now we can use the general term right here to represent the function f(s) right here. So this guy actually the sum when n start from 0 to infinity of negative 1 raised to the n s raised to the 2n over n factorial, right? Now let's move on to question B. Use your answer from part A to find the limit of this one, right? So we have 1 minus s squared subtract f of s. It's actually 1 minus s squared subtract the whole thing right here, right? So I just copy this one down. Now I'm going to distribute negative 1 and I'm going to simplify. So it turns out to be, now I'm going to divide by s to the 4, right? So if I take this one divided by s to the 4, it's going to be this guy divided by s to the 4, and the same thing as this guy divided by s to the 4, right? So I'm going to end up with negative 1/2 plus s squared over 6 subtract etc, right? Now I need to take the limit of this one, so I have limit of 1 minus s squared minus f of s over s to the 4 when s approaches 0. It's going to be limit of negative 1 over 2 plus subtract etc, right? When s approaches 0, this guy approaches 0, the answer is negative 1 over 2. Now let's move on to question C. Write the first four non-zero terms of the Taylor series for this interval. Use the first two terms of your answer to estimate this guy. Interval from 0 to s of e to the negative t squared dt is interval from 0 to s. Now we're going to use Taylor polynomial expansion for this guy, which we did in question A, right? So it's actually antiderivative of 1 is going to be t, right? This guy actually t cubed over 3 plus t to the 5th over 10 minus t to the 7 over 42 plus etc. evaluated from 0 to s. So it's going to be s minus s cubed over 3 plus s to the 5th over 10 minus s to the 7 over 42, right? So the first two terms right here. So the integral from 0 to 1 over 2 e to the negative t squared dt is actually x equals 1 half, right? So it's going to be 1 half subtract 1 half cubed divided by 3, right? So it's going to be 1 over 2 minus 1 over 24, right? So it could be 11 over 24, right? Now let's move on to question D. Explain why the estimate found in part C differs from the actual value of this guy by less than 1 over 200, right? So we have the absolute value of the integral from 0 to 1 over 2 e to the negative t squared dt subtract this guy right here 11 over 24, always less than the third omitted terms, which is this guy right here, right? But x equals 1 over 2, right? So we have 1 half to the 5th over 10, right? Now we're going to simplify. It's going to be 1 over 320, right? And this guy actually less than 1 over 200, right? Since this guy right here is an alternating series with individual terms that decrease in absolute value to 0, right? Now let's move on to question 16. Let f be a function with derivatives of all orders, and for which f of 2 equals 7. When n is odd, the n derivative of the function f at s equals to is 0. When n is even and n greater than or equal to 2, the n derivative at s equals to is given by this formula. Question A. Write the 6-degree Taylor polynomial for the function f about s equals 2. So the Taylor polynomial expansion is given by the formula. Now we have p set of s equals. Now when n is odd, the n derivative of the function f at s equals 2 is 0, right? So n is odd right here, n is equal 1 for this one, right? The first derivative. This is the third derivative, right? N equals 3. This is n equals 5, right? And derivative equals 0, right? So we only care about the first one right here. It's going to be f of 2, right? The center s equals 2. So a equals 2. F of a is going to be f of 2. This guy right here equals 0, right? Now this guy right here, n equals 2. We're going to use the formula right here, right? So we have f double prime of 2 over 2 factorial, right? Times s minus 2 squared, right? N equal 3, it could be 0. N equal 4, it could be plus the 6th derivative, right? Now we substitute value f of 2 equals 7 right here. Plus f the program, we're going to use the formula right here, right? So n equals 2, substitute over here, so we have 1 factorial over 3 squared, right? Times 1 over 2 times s minus 2 squared plus n equals 4, substitute over here, so we have 3 factorial over 3 to the 4 times 1 over 4 factorial times s minus 2 to the 4 plus n equals 6, it's going to be 5 factorial over 3 to the 6 times 1 over 6 factorial times s minus 2 to the 6. Now question B. in the Taylor series for the function f about s equal 2, which is a equal to, what is the coefficient of s minus 2 to the 2n for n greater than or equal to 1. Now observe that this guy right here, this guy right here, and this guy right here, they are the same, right? If I generalize this one, it's actually 2n derivative of the function f at s equal a over 2n factorial, right, times s minus a raised to the 2n. Now the coefficient is this guy right here, right? Look, they ask you to find the coefficient. So we have, now in order to find this one, we look at the formula right here. If this guy n, this guy n, and this guy n, now we have 2n right here, so we just replace n with 2n, right? So we have, now we're gonna simplify this one, 2n minus 1 factorial, rewrite this one, over 2n factorial can be written as 2n minus 1 factorial times 2n, right? Times 1 over 3 raised to the 2n, right? So this guy and this guy cancel out. We have 1 over 2n times 3 raised to the 2n. This one is the final answer. Now let's move on to question C. Find the interval of convergence of the Taylor series for f about s equal 2. Alright, so we're gonna go back over here. The Taylor series is right here, right? This one is the first 6 terms, right? You know that the first term right here is gonna be 7, right? And you look at the second term right here, you have the product right here. And this product actually right here, right? So we have, now in order to find the interval of convergence, we're gonna use ratio test, right? So we have limit of absolute value of a sub n plus 1 over a sub n when n approaches infinity. It's gonna be limit when n approaches infinity of, I'm gonna let this guy right here be a sub n, right? So we have a sub n plus 1 is gonna be, we need to multiply by this one reciprocal, right? So it's gonna be limit when n approaches infinity, absolute value of, we have 2n on the top right here, so we have 2n right here over 2 times n plus 1 on the bottom. Now this guy right here actually 3 raised to the 2n times 3 square, right? So this guy and this guy cancel out. We have 3 square on the bottom, which is 9, right? And this guy right here actually 2n plus 2. So we can rewrite this one as s minus 2 raised to the 2n times s minus 2 square. This guy cancel out. So we have s minus 2 square, right? Now we're going to simplify 2 and 2, right? So this guy turns out to be, we're going to use the relative growth rate, right? So n grows faster than 1. So it's going to be absolute value of s minus 2 square over 9. Limit absolute value of n over n when n approaches infinity. And this guy actually 1, right? So we have s minus 2 square over 9, right? And this guy always positive, so I can remove the absolute value side, right? I don't have enough space, so I'm going to write over here. So it could be s minus 2 altogether square over 9 less than 1, right? So it could be s minus 2 altogether square less than 9. Take square root both sides, so it could be absolute value of s minus 2 less than 3, right? So it's going to be negative 3 less than s minus 2 less than 3, right? Add 2 3 sides, so we have negative 1 less than s less than 5, right? Now we need to check for the endpoints, right? So the first one s equal negative 1 and the second one s equal 5. s equal -1. Substitute -1 for s over here. So we have, so it's gonna be 7 plus this guy cancel out, right? I'm gonna print 1/2 to the front, so it's gonna be 1/2 series 1 over n when n start from 1 to infinity, right? Now since this one is the harmonic series, it's always divergent, right? So if this one diverges, the whole thing right here diverges, right? Alright, substitute 5 for s over here. So we have, if you simplify this guy, it's actually 7 plus the series 1 over 2n when n start from 1 to infinity. So this guy actually, the first case, right, it still diverges, right? If you rewrite this one as 1 plus 1 over 2 series n start from 1 to infinity 1 over n. This one is harmonic series, so this could be divergent, right? So if this one divergent, the whole thing divergence, right? So your final answer must be -1 less than s less than 5. Now let's move on to question 17. The Maclaurin series for the function f is given by this guy and converges to FRS for absolute value of s less than r, where r is the radius of convergence of the Maclaurin series. Question A. Use the ratio test to find r. Alright, so we have limit absolute value of a sub n plus 1 over a sub n when n approaches infinity equals limit. Right, let this one be a sub n. So we have a sub n plus 1 is going to be -3 raised to the n, right, over n plus 1, right, times s raised to the n plus 1 divided by a sub n. We're going to multiply by its reciprocal, right? So it could be, now we're going to simplify this. The bottom right here can be written as -3 raised to the n times -3 power of -1, right? So this guy and this guy cancel out, right? So -3 power of -1, I'm going to bring it to the top. It turns out to be -3 power of 1, so it could be -3, right? And over n plus 1 right here. Now this guy right here can be written as s to the n times s. This guy cancel out, right? So I only have s left right here, right? So it's gonna be absolute value of 3s, right? And in order for this series to be convergent, this guy must be less than 1 by the ratio test, right? 3 times absolute value of s less than 1. So it's gonna be absolute value of s less than 1 over 3. Now we look at this one right here, absolute value of s less than r. This guy absolute value of s less than 1/3. So we're gonna match this guy. So the radius of convergence is 1 over 3. Now let's move on to question B. Write the first 4 non-zero terms of the Maclaurin series for f cram, the derivative of f. Now this one is the function f of s, right? So we just write the first 4 terms of the function f of s first, and then we're gonna take derivative, right? So now we're gonna take derivative of this one. It's gonna be 1 minus 3s, right? Plus 9s squared, right? Bring 4 to the front, so it could be cancel out right here. Minus 27s cubed, right? Now this guy actually geometric series where the common ratio equals -3s, right? Because every single time you're gonna multiply by -3s to get the net terms, right? So we have f prime of s equals the series k start from 0 to infinity of -3s raised to the k. And this series converges because we have this guy right here, absolute value of s less than 1 over 3, right? This guy actually absolute value of 3s less than 1. And this guy actually absolute value of common ratio less than 1, or absolute value of negative 3s less than 1. So by geometric series, the series convergent to a sub 1 over 1 minus r is going to be a sub 1 right here, 1 over 1 minus negative 3s, right? So it could be 1 over 1 plus 3s, and this guy actually the rational function, right? Let's move on to the last question. Write the first four non-zero terms of the Maclaurin series for e to the s. Alright, so we have e to the s equals 1 plus s squared over 2 factorial plus s cubed over 3 factorial, right? And this one is the first four non-zero terms, right? Now we're going to simplify this one. It's going to be 1 plus s squared over 2 plus s cubed over 6, right? Now use the Maclaurin series for e to the s to write the third degree Taylor polynomial for g of s equals e to the s times f of s about s equals 0. So we have g of s equals e to the s, which means 1 plus s squared over 2 plus s cubed over 6 plus etc. times f of s, which means s minus 3 over 2 s squared plus 3s cubed subtract etc. Right? So we just multiply this one out, right? So 1 times s is going to be s, right? 1 times negative 3 over 2 s squared is going to be negative 3 over 2 s squared. 1 times 3s cubed is going to be plus 3s cubed, right? S times s is going to be s squared, right? S times this one is going to be negative 3 over 2s cubed. S times this one is going to be plus 3s to the 4, right? And s squared over 2 times this one could be plus s cubed over 2. S squared over 2 times this one is going to be negative 3 over 4 s to the 4. And this guy times this guy is going to be 3 over 2 s to the 5th, right? S cubed times this one, it could be s to the 4, but we only need the third degree, right? So we can stop right here, right? Now we're going to simplify. S minus 3 over 2 s squared plus s squared is going to be negative 1 over 2 s squared, right? And 3s cubed minus 3 over 2 s cubed is going to be 3 over 2 s cubed plus 1 over 2 s cubed is going to be 2s cubed, right? This guy s to the 4 we can ignore, right? Because we only need third degree, right? And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.